Mars gets the spotlight. Mars gets the movies. Mars gets the billion-dollar missions and the dream of human footprints. But if you think Mars is the most dangerous planet near us, you've been looking at the wrong world. The real menace is closer, brighter, and far more extreme. Venus. At first glance, Venus looks harmless, almost comforting. It's about the same size as Earth. Similar mass, similar gravity. It's often called Earth's twin. But that nickname might be the most misleading label in planetary science. Because Venus is not Earth's twin. It's Earth's warning. Let's break the illusion immediately. The average surface temperature on Mars is about -60 degrees Celsius. Cold? Absolutely. Deadly without protection? Yes. But manageable with technology. Now here's the shock. The average surface temperature on Venus is around 465 degrees Celsius. That's hot enough to melt lead. And it's not a daytime spike. It's constant. Day and night. Pole to equator. No seasons. No mercy. If you landed on Venus with the same hardware we send to Mars, it wouldn't last hours. It would last minutes. The Soviet Venera landers, the toughest machines ever sent to Venus, survived for a maximum of 127 minutes before being destroyed by the heat and pressure. That was the record. Pressure. Let's talk about that. The atmospheric pressure on Mars is less than 1% of Earth's, roughly 6 millibars. It's thin. You'd need a pressure suit, but the environment itself isn't crushing. Venus is the opposite extreme. Surface pressure on Venus is about 92 times that of Earth. That's equivalent to being nearly 900 meters underwater in Earth's oceans. Imagine the weight of an entire ocean pressing down on you at all times. Now combine that crushing pressure with temperatures hot enough to liquefy metal and an atmosphere made of about 96.5% carbon dioxide. Mars may be cold and barren. Venus is actively hostile. But here's the pattern interrupt. Venus wasn't always this way. Evidence suggests that billions of years ago, Venus may have had liquid water, possibly even shallow oceans. It sits on the inner edge of the sun's habitable zone. So what happened? Runaway greenhouse effect. On Earth, greenhouse gases like carbon dioxide trap heat and make life possible. On Venus, that same mechanism spiraled out of control. As the young sun brightened, more water evaporated. Water vapor is itself a powerful greenhouse gas. More heat led to more evaporation. More evaporation led to more heat. Eventually, oceans may have boiled away completely. Without liquid water to absorb carbon dioxide through weathering processes, CO2 built up in the atmosphere. The result? A planetary oven that never switched off. And here's the uncomfortable controversy. Venus shows us what uncontrolled greenhouse warming can do to a planet. This is not speculation. Climate models confirm that Venus likely underwent a runaway greenhouse transition billions of years ago. It's a real planetary outcome, not science fiction. Now let's compare hazards directly. On Mars, you face radiation. Mars lost its global magnetic field around 4.1 billion years ago. Without that magnetic shield, solar wind stripped away much of its atmosphere. Today, radiation levels on the Martian surface are significantly higher than on Earth. Long-term human missions would require shielding. But on Venus, the thick atmosphere actually blocks a lot of radiation. Surprised? Yes, Venus's dense atmosphere provides strong radiation protection. If temperature and pressure weren't catastrophic, radiation would be less of a problem there than on Mars. But of course, you'd never get the chance to worry about radiation. You'd be incinerated first. And then there are the clouds. Venus is permanently covered in thick clouds of sulfuric acid. Not water clouds. Acid. These clouds reflect about 70% of incoming sunlight, which is why Venus shines so brightly in our sky. Beautiful from Earth. Corrosive up close. Any spacecraft descending through those clouds must survive droplets of sulfuric acid before even reaching the inferno below. Still think Mars is worse? Here's another twist. For years, scientists thought Venus might be geologically dead. But in 2023, NASA researchers analyzing decades-old Magellan spacecraft data found strong evidence of active volcanism. Surface vent changes near Mons suggest lava flows may have occurred in the early 1990s and possibly continue today. That means Venus is not just a static furnace. It may still be erupting. Volcanoes could be pumping more gases into an already suffocating atmosphere, maintaining the extreme greenhouse conditions. Mars, by contrast, is mostly geologically quiet. Olympus Mons, the largest volcano in the solar system, is enormous but inactive. Mars is a fossil of its former self. Venus is alive, angry, dynamic. Now let's talk about time. A single day on Venus, one full rotation, takes 243 Earth days. That's longer than its year, which is about 225 Earth days. And it rotates backwards compared to most planets. The sun would rise in the west and set in the east. Imagine standing on a world where the sun crawls slowly across a yellow sky for months, barely changing position, while the ground beneath you stays hot enough to glow. Mars may be lonely. Venus is relentless. But here's where curiosity spikes again. Despite all this, scientists are increasingly interested in Venus, not the surface, but the upper atmosphere. At altitudes around 50 to 60 kilometers above the surface, temperatures and pressures are surprisingly Earth-like. Some researchers have even proposed the idea of floating habitats in Venus's upper clouds, where buoyant airships could theoretically survive. Controversial? Yes. Impossible? Not necessarily. In 2020, a study reported potential detection of phosphine gas in Venus's atmosphere, a molecule that on Earth is associated with biological processes. The claim sparked global excitement, but follow-up observations in 2021 through 2023 failed to confirm strong evidence of phosphine. The debate continues, but as of now, there is no confirmed sign of life. Still, the mere possibility forced scientists to take Venus seriously again. New missions are coming. NASA's Da Vinci mission aims to study Venus's atmosphere and surface composition. Veritas will map its surface in high resolution. The European Space Agency's Envision mission is also on the way. For decades, Mars was the priority. Now Venus is demanding attention. And here's the final uncomfortable truth. Mars is difficult. Venus is catastrophic. Mars challenges engineering. Venus challenges survival itself. If Earth's climate systems were pushed far enough, Venus shows us the extreme endgame of greenhouse warming. Not next century, not anytime soon, but in planetary terms, it's a possible path. Mars represents hope, the idea that humans can expand outward. Venus represents consequence, the reminder that planetary conditions can spiral beyond recovery. So the next time someone says Mars is the most dangerous planet near Earth, remember this. Mars is cold and empty. Venus is hot enough to melt metal, dense enough to crush submarines, acidic enough to corrode steel, and possibly still erupting with volcanic fury. One planet froze, the other burned, and only one of them might still be trying to teach us a lesson. If you're fascinated by the hidden dangers of our solar system and want more deep dives that challenge what you think you know, make sure you follow for more. Now I want to hear from you. If humanity had to choose one planet to attempt permanent settlement in the next century, would you gamble on freezing Mars or risk the skies of Venus?